Hashgraph. I'm going to walk you through kind of what Swirlds is, what the Hashgraph algorithm is, what Hedera is, kind of what we're doing in the space, and then the Carbon Money guys will be here shortly. They are developing a stablecoin on top of the Hedera public ledger. So first off, I'd really like to talk about this. I'm pretty active in our Telegram channel, and a lot of people think that just in the last week that we have the same vision as Satoshi Nakamoto, which was just really not true. This Leemon's vision came from a very different place than what he was going for. But he says this in a series that we have on YouTube. We believe in a future where you can wave your hand and create a shared world for free. It's easy, trustworthy, reliable, and you can invite whomever you want and share whatever you want. You can collaborate and create movies, music, documents, 3D objects, and converse without dictatorship and complete fairness. A system that we can trust is going to work the way we want, and if a computer dies and I lose all my data, I can know the data is still safe. No servers, complete trust, security, speed, and fairness. So you can kind of see in this model, I don't believe he talks about a cryptocurrency anywhere. Of course, we need a cryptocurrency and a public ledger, but Leemon's vision was much bigger than that. So what is Swirlds? Swirlds is a company that has patented and invented the Hashgraph algorithm. It's a developer of a next-generation distributed consensus technology. We're based in Dallas, Texas. I think we're a bunch of us are remote, but we're somewhere over 30 employees now and scaling pretty rapidly. We incorporated in Q4 2015. That's when the algorithm was actually invented. The last 2 years, we've been testing this in permission private networks. So it's not like your traditional white paper going straight into a public ledger. This algorithm has been tested in a permission setting for quite a while. And we had $3 million raised on behalf of Swirlds, led by New Enterprise Associates. We have since March 13th in New York City in Times Square, we announced the Hedera public ledger that we were intending to do, and we have raised $18 million for Hedera. On this right here, you have kind of the generations, at least what we believe. Everybody kind of has their own, generations that they go by, but we kind of see ourselves in this fourth generation. Of course, cryptocurrencies came first in 2009 with Bitcoin. Shortly after that, there was private permission networks that were doing ledgers. If we can store a cryptocurrency, why can't we store something like audit trails or property deeds or things like that? Then, of course, we had in 2015, we had Vitalik Buterin with smart contracts. So if we can store those two different kinds of assets, why can't we do a simple contract to facilitate the actual swap? And then the last thing here is fair markets. So what do you need to do fair markets? You need time stamping and ordering on all of that. A little bit about the founders. You have Mance, Harmon, and Leemon, Baird. These guys met in 1993, working for the senior scientist in machine learning. They both taught at the United States Air Force Academy, both in cybersecurity. Mance kind of more on the leadership side. He has a master's in computer science from UMass. Leemon, he's an extremely brilliant guy, holds a record at Carnegie Mellon for the fastest PhD in computer science there, 2 years and 9 months, and he has over 100 publications in peer-reviewed journals on computer science, machine learning, and mathematics. Together, they have formed 2 companies. This is their 3rd one, and they have sold both of those companies. So we'll get a little bit into the actual technology and what is Hashgraph. So Hashgraph is not a blockchain at all. It's actually a DAG, a directed acyclic graph. You can see what that looks like. Here's your linear blockchain. Here's a DAG. It's a very simple, elegant algorithm. It's mathematically proven, and it's implemented in software already, as I kind of mentioned before. It already exists. You can go online and download the SDK right now. And it's also the only bank-grade consensus in the market. What that means is we have a property that's called asynchronous Byzantine fault tolerance, and it's the strongest form of consensus you can actually have. So quickly what I'm going to do to kind of just ground level for how many people actually know of Hashgraph and are pretty familiar? Okay, about half of you guys, that's pretty good. Okay, so what I'm going to do is kind of show you the last, 8 years and where this technology has gone. we're going to look at the differences in performance and security for a bunch. So again, as kind of a table of contents, we're going to jump into leader-based systems, proof-of-work blockchain, economy-based systems, voting-based systems, and then kind of show you how Hashgraph comes in after that. So leader-based systems. These can do about 1,000 transactions per second, so they're really good for POCs, but they have a very fundamental security flaw in that all of the members, these are all the members of the network. So if you can imagine this is a bank, all of these members have to depend on the leader to organize these transactions and send them back out to the members. So if one of these members is compromised by a virus or malware or maybe just a disgruntled employee, and it can actually direct a denial of service attack, that's where you basically spawn up a bunch of computers, maybe you have compromised baby monitors or printers, or you just go to DigitalOcean and just buy a bunch of servers, whatever it may be. You can then direct all of those computers at this leader by sending the IP address out of the network, and you can do that in full anonymity because it's just a couple bytes, it's just a few numbers. What will happen when that takes place is that this leader will actually go down, it'll go offline, and by design, a new leader will be elected, and then you can't tell who's actually compromised, but they have to know the IP address of that leader by design, so this computer, this malicious computer, just redirects that attack, that DDoS attack. So it's very susceptible to DDoS attacks. These are used a lot in permission-based networks where you don't have such security flaws, but it's not the hundreds of thousands of transactions per second we're looking for. Good for the POCs, as I mentioned, and it has kind of a big security flaw. So proof of work obviously came with Bitcoin in Satoshi Nakamoto's vision. So what happens here is that a transaction is actually submitted into the network. These miners then fight over an extremely difficult cryptographic puzzle, basically guessing numbers until they get the right number. When they guess that number, they then announce it to the community, and they get to add that block onto the chain. The problem here is that it's extremely slow by design. The developers have to make it more difficult. The puzzle has to be difficult enough that the system is slow enough that it doesn't spiral out of control. If it was going too fast, you would end up getting a Hydra head, and too many people would be putting on blocks, basically. The other thing is that it's extremely unfair. So the miner that actually wins this puzzle gets to decide where transactions go in a block. They get to decide what transactions actually go inside a block. So they could be bribed to just ignore your transaction. So you'd say it's not fair. And again, it's extremely slow, but it is very secure, and that these systems haven't been hacked exactly. So what a lot of people are trying to do in terms of to solve this transactional throughput is being so slow, because Bitcoin, I think, is somewhere between 5, 10, 15 transactions per second, and Ethereum a little bit faster. A lot of people are moving to these economy-based systems. These are basically proof of something, proof of stake usually. And what happens here is that there's kind of a fundamental assumption that is made that every node in this network will act in their own best interest, that they will do whatever they can to make the most money. It's a very bad assumption to make because it doesn't take into consideration things like viruses, and people do act irrationally. Something we often say is, could you prove that the US stock market will never crash again? Of course not. You can't write a math proof that says that. But if we're going to trust a public ledger with trillions of dollars worth of assets, we should really try to have a math proof that says that a single attacker cannot do significant damage to these systems. And they cannot actually answer that question. So we'll see. None of these has really been fully deployed in the space, but they are coming. If you go 35 years back in computer science, there was voting-based algorithms. These were like the fundamental at the very beginning of the internet. I think it's the way they wanted to build the internet, but they couldn't actually figure this out back 35 years ago. In these networks, you would have every computer basically, the transaction come in, they have to vote yes or no on this transaction. every computer would have to talk to every other computer. It's basically n squared work. Extremely inefficient because every computer has to talk to every other computer. However, you can see if that kind of communication was taking place, you have a very strong form of consensus. These are where the asynchronous Byzantine fault tolerance comes from. These have the gold standard of consensus. So the question was, how can we do a voting-based system without actually doing the votes, the inefficient part? And that's what Hashgraph does. Basically how Hashgraph does that is every time you're going to talk to someone, you're going to include your own hash and the hash of the last person you've talked to. That continues to gossip out. So I'm going to talk to you, and then you're going to go talk to somebody else, and when you're talking to somebody else, I'm going over here and telling them that, and we all just spread through gossip. And after a certain amount of seconds, usually about 2 to 3 seconds we've proven, everyone will have a picture that's built up of the hash graph. They can then look at the hash graph in their memory and input that data into one of those old voting algorithms, into one of these. And by doing that, we can solve that whole inefficiency and actually get some amazing things. So we can do hundreds of thousands of transactions per second. We have the gold standard asynchronous Byzantine fault tolerance for consensus. And we also have new things, new properties called fairness. So we have fairness of order timestamps, and we have timestamps on every event. So what basically happens is every event that happens from a node, we also include, I'll just show you this in a second, what's actually in an event. But we have the 2 hashes that I mentioned in the timestamp. And the timestamp itself, you look at all the events and you take the median timestamp, not the mean. So we'll take the median timestamp of all the timestamps we get, and we'll get a community timestamp when the community agrees that that event actually took place. So here you have a little bit of the summary, kind of what I just went through with obviously Hashgraph being unique in the space. Quickly, I'm going to kind of go over again what gossip looks like. So here you have Alice that has a transaction. She's going to send that transaction to Dave, and then they're both going to tell 2 people who tell 2 people, and then everybody has the transactions. So that's one way, right? What happens if 2 people do it at the same time? So Bob and Carol both have transactions here. They both send 2 out. They send, again, exponentially going out. And there you go. And then, but you'll notice some of the order's not right. So that's where the timestamps come in that I just mentioned. Here's kind of what the hash graph actually looks like. So these are nodes, obviously here, Alice, Bob, Carol. These are all the communications that are happening, and that builds up, and that data right there is what gets inputted into those old voting algorithms. So gossip is basically just, let me define that too. Gossip is just calling up a random node and telling you what you know. This is not a novel idea. It's used in Bitcoin, Ethereum, and other areas in computer science. Gossip about gossip was the breakthrough that Leemon had. And that was basically additionally talking about the action we had. So we talk about the gossip, but then we're going to also talk about who we gossiped with and the last person. And then the virtual voting is, again, we can just run that voting algorithm in our head. We can look at the data, everyone has the same data, and we all come to the same consensus. So there you go, you have the 2 hashes. The hash of yourself previously, the hash of the last person you've talked to, whatever transaction may be in their payload, and the timestamp. And of course, there could be dishonest members in there, and maybe someone's putting, they did their transaction in year 2050, or someone else put their transaction in at year 1900. That's again why we take the median. Any of those dishonest nodes will get picked out. So what are the new use cases? So the 3 main ones that we are really excited about are fair markets, fair auctions, and actually games. You can of course do micropayments, and this will be the first, I think, really good demonstration of micropayments really being successful. And I'm really excited personally about the games. I think in the future we'll have games like World of Warcraft really deployed on here, which will change the gaming industry a lot. When independent developers no longer have to. I think Machine Zone is a company that's deploying on us, and they have I think, a $200 million server infrastructure for their iOS games all across the world. When you can relieve that and not need to have a server infrastructure for gaming, yeah, it's going to be a very different place. So very excited to see that. Here is the SDK. If you want to download it, if you're a developer, you can do that now, swirlds.com/download. That comes with this is the config file, which shows you kind of the IP addresses. The SDK currently is used mostly for permission-based networks. So if you wanted to develop a POC, you can download this. You can test the Hashgraph algorithm too. We actually tested it using Raspberry Pis, which are $30 computers. So this algorithm is that small that it can process, you don't need a massive server rig to run this. In this case, you would define all your nodes here, and you can test accordingly. It comes with some demo apps. So here's a game. Here's the Hello Swirlds, and you can actually kind of see it coming to consensus. I know it's probably hard to see, but you can see it coming to consensus and reordering things as it's going. And then we'll talk about the public ledgers. So that's like probably the most exciting thing. So obviously I mentioned earlier, March 13th in Times Square, we announced Hedera, which is, the last year it's always been a vision for Mance and Leemon to do the public ledger, but they wanted to test the algorithm first, know that was working, and then they kind of addressed the issues that we see in the space. So they spent the last 6 months to a year kind of looking at the public ledger space and trying to figure out the problems and what people were talking about, why this is not becoming a mainstream thing. So a couple of those things were performance, security, governance, and stability. So we believe that you need hundreds of thousands of transactions per second with seconds of latency. We need to eliminate threats and ensure fairness. We need mathematical proofs that guarantee our security. We need governance, so we have to have experts for technical, financial, legal, all the regulatory things that are going to come about when we deploy these worldwide networks. And finally, stability. So one of the things that we've seen is that when you create the open source communities, obviously we love them, and they are catalysts for change. But when you combine them with a cryptocurrency, the incentives to fork and to do your own thing and to break off is so great that it creates a chaos, and we aim to solve that. So what did we do? We have the hundreds of thousands of transactions per second. We have the asynchronous Byzantine fault tolerance, which we have the math proof of the strongest security possible. And we came up with a governance model that was 39 global blue chip companies. They do 10 billion plus in revenue. They will be the best in class enterprises. We will have 2 per sector, no more. So we might have 2 banks. We might have 2 insurance companies. We might have 2 telcos and 2 fast moving consumer goods. We believe that these companies will not collude with one another because of their separation in sector. And lastly, the stability. So again, we are an open review. Many of you probably know that. We are open review, so it's not open source. What that means is because we have a patent on the technology, that we're not going to come after you if you decide to steal the code, but we're going to use that to guarantee to especially enterprises and developers who are worried about spending $2 million to develop a DApp on one of these public ledgers. They want to know that tomorrow it's still the same chain. They get really worried when things are forking and they don't know what's going on, and they're just not going to invest in something that tomorrow could fork, and they don't know what's going on. It becomes chaos again. So one thing with that, we are open review, but we do not require permission from anyone to develop an app or use the public ledger. It's completely public. You don't have to talk to us. There's no license. The software you develop is completely yours. You never have to talk to us. The normal public ledger. And the source code will be public review with version 1.0. I think we're looking at a Q4 public launch at some point in time. So again, we have the TCP/IP, the internet right here. Sitting right on top of that is the Hashgraph algorithm, the Hashgraph SDK. It will come with 3 services: a cryptocurrency with native support for micropayment, a file storage system, and the Ethereum virtual machine will be sitting right on top of it. We've seen that, there's I think over 1,000 apps on Solidity now on Ethereum. So why not just plug that right in there? Yep, and that's it for me. So